All right. So we're going to kind of keep going with sets. All right, so let's talk about sets. You told me that equal sets are sets with exactly the same elements. And you told me equivalent sets are sets with the same number of elements. What's a cardinal number? I gave you that definition last time. What was cardinal number? Do you remember? The number of elements in the set. Now, notation-wise, I told you that sometimes you get tired of writing things. You know, if I have to write that set over and over and over again, then drawing those braces, you know, gets kind of yucky. So a lot of times, when they have to do the same set repeatedly, rather than writing out exactly what the set is, they'll name the set. And sets are named with single capital letters. So every time I said A, then you would know I'm talking about A is the set with what in it? 1, 2, 3, and 4. Now, there's something called a universal set. Now, the universal set is a set with all the things in it kind of in your universe. It's going to change from problem to problem. They're going to have to tell you what the universal set is. So, a lot of times it'll do something like this. What that means is, right now, the only numbers, the only things that exist in your universe are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I say 11, like that has no meaning to you. 1.5, don't know what you're talking about. -1 doesn't exist. Is everybody with me? So these sets are going to have to come out of those sets. They would never have another set down here. Now B might be the set with just 2 and 4 and 8 and 10 in it. C might be a set with 1 and 5. You see what I'm saying? But they would never have C be 11 and 5. Why? Because 11 is not in the what? Universal set. And in a different set of problems, they'll change the U. Okay? Now, the notation I want to show you is this. I could say, what is the cardinal number of set C? Okay, look at set C. What's the cardinal number? 2. Why? That's how many things are in the set. So the answer would be 2. But they're not going to write it like that. They're going to write it like this. They're going to have a lowercase n and then put the set name in a parenthesis. So I need you to understand that this says exactly the same thing all that says. And so that's the way I'm probably going to put it on the table. This is asking you what's the cardinal number of set C. And we agreed, what is it? So a lowercase n stands for cardinal number. But you've got to know cardinal number of what? Because that's not going to be the same thing if I say this. What's the cardinal number of A? Is it 2? What's it? 4. Okay. So sometimes, remember we talked about there are different symbols for things, so we've got to make sure that we're cool about that. Now, let's talk about the idea of subset and proper subset. Okay. Now, all right. Let's do it this way. A, now, do you see it looks like a C with a bar under it? That stands for subset. Okay. A is a subset of B if every element of A is also an element of B. Okay. Now, I wouldn't really memorize it with A and B. Think about like left set and right set. This left set's a subset of this right set. if every element in the left set is also a member or an element of what? The right set. So look over here at your example. True or false? D is a subset of A.
True.
True. Now think about why. Because D has a 1 and a 3 in it. And A has a 1, a 2, a 3, and a what? A 4 in it. So everything over here, the 1's over there and the 3's over there. So this is what kind of statement? True or false? True. Well, what if I said C is a subset of A? Why? Because there's no 5. In other words, in C, this time I got a 1 and a 5. And in A, I got a 1, a 2, a 3, and a 4. So 1 is in there, but what? 5 what? Isn't. So that would be a false statement. Okay. So everything in the left set has to be inside what? The right set. Now let me ask you this. Okay. True or false? D is a subset of E. It's true, isn't it? What's in D? 1 and 3. What's in E? 3 and what? 1. Is everything in here, 1's over there and the 3's over there. So is everything in here in here? Now, what other kind of sets? What else could you say about D and E? They're actually what kind of sets? They're equal. Why? They're exactly the same. What else could you say about them? They're equivalent. There's a lot of things I could say about D and E. But if somebody said D is a subset of E, that's still a true statement. Okay? So does everybody understand what subset means? Okay, because we're about to switch something. Okay? Now let me go over here. A. Now I'm going to put just the C. There's no bar under it. Now that's the symbol for proper subset. All right, proper subset. A is a proper subset of B if every element in A is also an element in B and A has fewer elements. So do we understand that subset has one condition, but proper subset has what? Two conditions. So I want to know this. True or false? D is a proper subset of A. I mean, a minute ago, you told me that D was a subset of A. You told me that was true. Well, remember what D had in it. D had what? 1 and 3? And A has 1, 2, 3, what? 4. So let's make sure we understand the difference in these things. Okay. When I'm doing subset, I only check one thing. Is everything in the left set in the right set? Is it? True. Over here, I got to check two things. The first thing I check is the same. Everything in this left set's got to be in that right set. Is that check? What else has to be true? This has to have fewer things than that has. That's got 2 things. How many's that got? 4. Isn't 2 less than 4? Yes. Both of these are true.
If it were to say, A is a proper subset of D, could we just like automatically know?
Okay, so you're asking if it says is A a proper subset of D, then the first thing you might check is the number of elements, right? So if she sees that D has more things than A, then D could never be a what? Proper subset. So you don't have to check them in this order. So if you notice this one's going to be false, I check that one first and be finished. Okay? Now look at this one. You already checked this one a minute ago. A minute ago on number, what was it, 3, you checked to see if D was a subset of E. And D had 1 and 3, and E had 3 and 1, didn't it? So what did you say on subset? Is D a subset of E? Yeah. Okay. Is D a proper subset of E? No. The first part checks. Everything in the left set's in the right set. But what's the problem? This doesn't have fewer things in it than what? Than that does. So that one's false. Okay? So you can be a subset without being a proper subset. You can be a Mazda without being a Mazda tribute. You see what I'm saying? So, but if you're a Mazda tribute, you're sure going to be a Mazda. Is everybody with me? So if you're a proper subset, you're always going to be a subset. But because you're a subset doesn't mean you're a proper subset. So subset has one condition on everything in here has got to be what? In here. But proper subset has how many conditions? 2 conditions. Now, I'm going to give you an analogy, okay, to help you remember it, and show you why they did this symbol. What's that symbol say? Less than or equal to. Now, a number can't be less than and equal at the same time. That's why that's not less than and equal to. That's less than or equal to. So, do we understand that this is a true sentence? 2 is less than or equal to 3. And why is that true? Because 2 is what? Less than 3. 2 is less than or equal to 2. Is that true? Yeah. Why? Because 2 is what? Equal to. But you couldn't say that 2 is equal to 3. Is everybody with me? And you couldn't, so you couldn't say 3 is less than what? 3. Is everybody with me? Now, let me show you something. What is this symbol? Is that the symbol for subset or proper subset?
Subset.
For subset. Notice what it's a combination of. Proper and what? Equal. See, with a subset, it can either be a proper subset, you see what I'm saying, where this goes into that and has smaller, but it's also okay when the sets are what? Equal. So that's why that's the symbol for subset. But for you, all you got to remember is, with subset, how many things do you check with subset? Just one. Just one. Everything on the left and the right. With proper subset, how many things do you check? 2. Everything on the left and the right, and the left set has to be small. Okay? All right, good deal. All right, now, I told you last time we talked about an empty set. Okay, what's an empty set? A set with what? Nothing in it. Okay? There are 2 symbols for empty set. Now, there's another phrase that means the same thing as empty set. Some books say null set, N-U-L-L. Those are 2 ways of saying the same thing. Just like counting numbers and natural numbers are 2 ways of saying the same thing. So the test might say null set or the test might say empty set. Now, there are 2 different symbols, and it's a personal preference which one you use. You can either put braces with nothing in it. That stands for the empty set. or a 0 with a slash through it stands for the empty set. But I do not want a funky combo. Like, if you tell me this, I'm going to count it wrong. That's the set of the empty set, which is something different. So either give me this or give me that. Is everybody with me? That's the reason I should never see you or a kindergartner or a 10th grader write 0 like this. That is not 0. That is the empty set. They are two completely different things. So this is not the empty set. It's got a number in there. It's got a 0. 0 is a number. The empty set doesn't have anything in it. Okay? So sometimes in elementary school, you let kids do things you don't need to let them do. And that's one I've seen. That is, don't let them use that for a 0. That's not 0. That's a whole different thing in a math class. Okay? Now, our goal eventually is to where we can add, subtract, multiply, and divide numbers. But we're not there yet. Okay? So what I need you to understand is sets is below that. Like we hadn't gotten up to adding 1 and 3 yet. Okay? Some people think, well, this math is high. No, this math is low. It's below kindergarten math. Okay? This is what you used to teach kindergarten math. So since we can't do those same operations with sets. You never add, subtract, multiply, or divide sets. But you do have set operations. Okay? All right. So let's talk about the set operations. So we are going to combine sets to make new sets. But we're not going to combine them with those 4 traditional operators that you're accustomed to. All right? The first one we're going to have is called union. You can union sets. And the symbol for union is a U. Okay? So, A union B is the set of elements in A or in B or in both. So I've given you a universal set up there, the natural numbers from 1 to 8 inclusive. And I've told you that A has the set 1, 3, and 5 in it. B has the set 3, 7, 8 in it. And C has the set 2, 4, and 5. Then what if I asked you this on a test? What if I told you to go find me A union B from that example? So do you understand? It's like you have a jug with stuff marked A, and you've got a jug with stuff marked B. The union is you dump in all of A, you dump in all of B. Is everybody with me? All of that stuff is the union. So tell me, what would be the answer to A union B? What's in this set? 1. What else?
5, 7, 8.
Is 3 in there?
Yes.
Yeah. Is 5 in there? Is 6 in there? No. What else is in there?
7.
And what?
8.
1 is only in A. 5 is only in A. 7 and 8 are only in what? B, and 3 is in what? Both of them. Bear with me. So it's union is all of it. Think about a teacher's union. Who's in the teacher's union? All the way. All the teachers. Is everybody okay? Now, intersection. Intersection. Now, your symbol for intersection is like an upside down. A intersect B. Just like that. A intersect B. So that's the set of the elements in A and in B. Now, in math, when you say the word and, it means at the same time. It means simultaneously. So if I wanted A intersect B, are there any elements that are in A and in B at the same time? Yeah. What is it? 3. Now, you better be real careful with these connector words, with these conjunctions. Union, the connector word is what? Or. Intersection, the connector word is what? And. Do not flip them around, or don't tell me that union's everything in A and B. No, it's not. That's intersection. Union's everything in A or B or both. So you can't switch. If you don't get these straight now, when we get to the word problems, you're going to get lost. So somehow you've got to remember that union goes with or and intersection goes with what? And. Now think about it. If you were outside over here by Cockroft and Hatterman and Sale, there's an intersection in the road, right? So think about what that means. Technically, the intersection is this piece of asphalt. Why? Because if you're standing right there, you're literally standing in two places at once. You can say that you're on this street, if you tell them the truth, and at the same time, you're what? You're on that street. So do you understand the intersections where they overlap? So union is all of it, and intersection is what they have in common. Okay? Does that make sense to everybody? Okay. You've got one more operation, and we're going to play with them. All right. Here's your third one. Your third one is complement. And make sure you spell it correctly. It's not compliment with an I. It's not don't you look nice. If I tell you that my personality and my husband's personality complement each other, does that mean that we're exactly alike? No. What does that mean? What I don't have, what? He has. So we kind of make up for each person's deficits. Everybody with me? All right, that's the way complement of a set's going to be. The symbol, there's lots of symbols for complement. I'm going to use a bar because your book uses bars. So if it had something like this, a bar, that means the complement of set what? A. It's the set of all the elements in the universal set that are not in A. In other words, it's like the universal set with A deleted. So the connector word, so to speak, the word that's real important for complement is the word what? Not. So that's like the complement of A means not A. So if I wanted to find the complement of A, the first thing I'm going to do is go over to the side and write down the universal set. All right, what's in my universal set over there? The numbers from what? 1 to 8 inclusive, all right? So that is my universal set. Now, what am I going to do? I've got to take out everything that's in what? That's in A. So look over there and tell me what's in my set A. 1 what? And what else? Now, are the numbers I crossed out in my answer? No, it's what's left. So what's the complement of A going to be over there? 2 what? 4, 6. Okay. So if I'm going to do complement, what am I always going to start with? Universal set. Okay. And everything that we do is going to be a mixture of these 3 operations. So you can union sets, you can intersect sets, and you can take complements and sets. All right, so let's go play. Make sure we're good. All right, here's your union up here, your universal set up here, and your A, your B, and your C. All right, so I want you to go do this one first. All right, I want you to go find B union C. Now, is union all of it or what they have in common? All of it. So what should be in my set? B union C. 2, what else? 3, what else? 4, 5, what? 7 and 8. Now, let me show you something. Is this the same answer as this? Are they equal? They are, aren't they? You see how long it took you to figure that out? That's why this is going to be a GAN rule, not a math rule. This is a correct answer, but I don't want it. Okay? So if you're giving me a set, I want the numbers in numerical order. If it's alphabetical in alphabetical order, it's just easier for me to grade. Because if I've got 100 around, I'm afraid I'm going to miss something. You're going to miss some partial credit. Is everybody with me? But I do want you to understand, if you were a math test and this was a choice, would you pick it? Yes. So what I'm saying right now is not a math rule. It's what? It's a GAN rule. Now, the reason I'm telling you that is you need to do the same thing. There's some things as a teacher, it's just your personal preference. But you need to tell the students when you want something a certain way, is it because it's a math thing or is it a Brown thing? You see what I'm saying? Is it a Stewart thing or is that an English thing? You see what I'm saying? So they know, because what they're going to assume is if you do it all the time, they're going to assume doing it another way is wrong. So you need to be very clear about whether something is right or wrong in the discipline or a preference on the teacher. So you're the teacher. You've got the right to say, I'm going to count off if you don't put your numbers in numerical order. But you need to be very clear. That's just a GAN thing, not a math thing. Okay? All right. Then go do this one for me. A intersects C. Now, is intersect what they have in common, or is intersect all of it? Okay, what do they have in common? Here's A and here's C. They both have 5. We okay? All right, find this one for me. The complement of C. So if I want to do the complement of 7, what's the first thing I do? Write down what? Universal set. So I've got 1, 2, 3, 4, 5, 6, 7, 8. And then I delete or I cross out everything under the bar. So everything in C gets crossed out. So what's going to get crossed out? 2, the 4, and the what? The 5. So what's the answer? 1, 3, 6, 7, and what? 8. So does everybody understand the basic operation? Okay, then I want you to do this one for me. The complement of B intersect A. Now there I had to do one thing, I had to do what? Two things. So the first thing I would expect you to do on test is show me the 2 things. Everybody with me? So in other words, what's in your complement of B? When you wrote down the universal set and you deleted the 3, the 7, and the 8, what was left? 1 what? 2 what? 4, 5, 6. Is that it? So does everybody understand that was the complement of B? Now intersecting that with A is 1, 3, and 5, isn't it? Now if they intersect all of them, what they have in common? Right. Do they have anything in common? Yeah, what do they both have? They both have a what?
1 and
A
5.
1 and a 5. They both have a 1, they both have a 5. So my answer is just 1 and what? 5. But do you understand that would be the way to show me your scratch board and your partial credit? All right, do this one for me. Now, there's not any parentheses. Is everybody with me? So I've got to go left to right. So the first thing I've got to do is A intersect what? B. All right, here's A, 1, 3, and 5. Here's B, 3, 7, and 8. So I do this first. Do they have anything in common? They both have a what? 3. Now what have I got to do with this answer? I've got to take this answer and intersect it with what? With that number, with C. Correct? Now, does that mean all of it or what they have in common? What do these 2 sets have in common? They don't. So what's the answer? The empty set. So you can either have a 0 with a slash code, you can have those braces with what? You got to get them. All right, do this one for me. And you got to follow the order of operations in sets, just like you follow the order of operations in numbers. What's the first thing we decided we did? Parentheses, right? All right. B, what's that symbol say? Intersect. Does that mean what they have in common or all of it? All right, look at B and look at C. B's got 3, 7, and 8. C's got 2, 4, and 5. What do they have in common? They don't have anything in common. So the answer to this piece is just that empty sets. Everybody with me? I'm supposed to union that with A. Now what does A have in it? 1, 3, and what? 5. So I need all of it. So this is like taking a bucket that's empty and dumping it in. Does it change anything? So what's my answer? 1, 3, and what? 5. The empty set doesn't add anything. Everybody okay? Now, what if it had been an intersection right here? What instead of it being A union, what if it had been an A intersect? What would these two sets have had in common? Is it the same in both? No. So what would the answer have been then? Empty set. So you got to notice whether it says union or whether it says intersection. Now, on this next one, I've moved where the parenthesis is. I want you to see if you get the same answer. So instead of doing B intersects C first, what do you got to do first now? A what? Union B first. Did you get the same answer? You don't, do you? All right, so look at what you got when you do this one. You had to do first A union B. So what's in A union B? When you put A and B together, what do you get? 1, what? 3, 5, 7. I've got to intersect that with C. Now C is 2, 4, 5, isn't it? Do they have anything in common? So if you change where those parentheses is, if you change the order, you change the answer. So that wasn't, we're going to talk about this later, that wasn't commutative. Commutative means you can change the order without changing the answer. So you've got to be very careful when you're doing these problems to make sure that you are following the order of operations. So part of your homework, now we're not going, but part of your homework is going to be giving you problems like this when you've got a universal set and some subsets. Aren't these all subsets of that universal set? And then getting you to union, intersect, or complement. And if the problem's really long, it doesn't make any difference. You can only do one thing at a time. You're either unioning, intersecting, or complementing. And you just keep putting them together until there's nothing left to do. Okay? Now, I want to talk to you about this for a second. You heard the phrase that a picture's worth 1,000 words. Okay? Well, a Venn diagram are pictures of sets. Okay? A Venn diagram is a picture of a set. Okay? They were created by a man named John Venn. Hence, you come up with what you get to call it out. Okay? Now, I'm going to kind of set it up. We're going to do a lot more of it next week. Okay? But I want to kind of set up the possibilities so you understand when I start drawing on the board on Tuesday why I'm drawing what I'm drawing. Okay? So here's what I'm saying. If I have two sets, A and B, and you don't know anything about them, all right? So I'm like, we're not talking about the A and the B on the other board, so I'm going to erase them. They're gone. All right. There are some possibilities. All right. It could be, a minute ago, when we intersected B and C, did they have anything in common? They didn't. Now, when you're drawing pictures of sets, the universal set is a rectangle. So you draw a rectangle. Okay? Now, weren't the A, the B, and the C, and the D, and all that, weren't they subsets of the universal set? So I need these to be subsets of this, which means they're going to be inside. So the sets are drawn as circles. So it might be that this was the situation. In that picture, do A and B have anything in common? No. So if you intersected them, what would you get? You'd get the empty set, the null set, wouldn't you? That's what's called disjoint sets. That's a picture of disjoint sets. They have no elements in common. And you can physically see they don't have anything in common. Okay? So it might be that A has 1 and 2 in it and B has 4 and 5 in it. There's no overlap. Okay? Now, that's not true for all sets A and B, but it could be true, right? So we're doing all the possibilities. Now, here's another possibility. So the example of this would be, like I said, if I had a 1 and a 2 over here, and then I had like a 3 and a 4 over here. They don't have anything in common. Okay? Now, it could be that you had something like this. All right? Here's A, and here's B. Now, if that's the case, what do you notice about B compared to A? Isn't all of B inside of A? What do we call it when a set, everything in this one's in that one? What was that thing we just went over a while ago? This is a picture of B being a subset of what? Of A. So this would be something like this. See, what if B had 1 and 2 in it? But A had 1, 2, 3, and what? 4 in it. Isn't everything in here in here? Well, if I put 1 and 2 in B, doesn't it automatically stick it in A? Where would the 3 and the 4 have to go? They would still be here. You could put 3 up there as long as it was in A but not in what? B. And sometimes that happens. We've seen that a minute ago where one was a subset of what? Another set. All right, here's a possibility. All right, you see set A. There's set B. Where did I put set B? Right on top of what? Set A. So what do you think that's a picture of when two sets are what? Equal. So far, if we have two sets, we've got three possibilities. They might have nothing in common, might be disjoint. One might be inside of the other one, right? They might be the same. Now, which possibility have I left off? They overlap, all right? So, here's your fourth possibility. It could be that A is here and B is here. Now, those are called intersecting sets. So that would be something like, suppose A had 1, 2, 3, and suppose B had 3 and 4. What do they have in common? 3. Where would I have to put 3 in the picture? Do you see that 3 would have to go somewhere here? Because that puts it in the A circle and also what? In the B circle. Where would I put 1 and 2? They've got to be in A. Can I put it right there? No, why? That's sticking in B. So it's anywhere in A but not in B. Where's the 4 going to go? Would I put another 3 over here? No, I've already got 3 in B. What am I missing? 4. The 4. Now, the reason that people like Venn diagrams is they're quick and easy to read. See, if I gave you this and says, what's A intersect B, you can get 3, but it's going to take you a second. If you look at the picture and I said, what's an A intersect B, what? 3. I mean, it's physically in the overlap, so you can see. Now, do you understand that complement, if I said, what's the complement of A in this picture? That would be like I had a big piece of rectangular material and I cut circle A what? Out. So it'd be like you went to A and you covered it up. Is everybody with me? So 4 would be in it. Now, what would it mean if there was a 5 out here? That would mean that my universal set must have been 1, 2, 3, 4, what? 5. In other words, 5 is in the universal set, but it's not in A or in B or in both. So if I did that, what would the complement of A have in it? It'd be like I covered up A, it'd be not just 4, but 4 and what? 5. Most sets are probably overlapping. Now, suppose you had 3 sets instead of 2 sets. So let me ask you this. If I had 3 sets, why is it not going to be okay to draw them like this? Why would that be a problem? Because what now? Yeah, what if A and C have something in common? What? I can't show it in the picture. Is everybody with me? All right. So, Kevin said I can't do that. So, what if I drew it like this? So, what's going to happen is this. If you have 2 sets, they're almost always gonna draw them like this. Now, I'm gonna back out so the people can see this other. Okay. You see this first picture where it's 1 and 2 and 3 and 4. This is the best picture, but I can still make it work with this picture. I can still get accurate information. What would be inside this little piece? Nothing. In other words, I would have the 1 and the 2 and the 3 and the what? The 4. Now, I agree that this is really a better picture, but this one's still true. All right, look at this one. I've got a 1 and a 2 in B and a 1, 2, 3, 4 in A. Could I give, that's a better picture, but could I still get the same information with this picture? Where would I put the 1 and the 2? If I put 1 and 2 in the middle, is that in A? Where's the 3 and the 4 going to go? Just over here. Is everybody with me?
It would go on.
So sure enough, I mean, so it would be an A, wouldn't it? So that's a better picture, but this is still true. The only thing in B is 1 and 2, but in A I've got 1, 2, 3, and what? 4. Now it's easier to see at a glance that this one's a subset because it's all inside, but this still tells the truth. All right, look at this one. I have a 1 and a 2 in both. That's a better picture, but I could still make it work with this picture. Where would I put the 1 and the 2? Just in the middle. So a lot of times what you're going to see is people draw this picture all the time. Because you can make this one work. Are you with me? So while these pictures might be better, this one's still true. So if you don't know anything now, if you knew before you started there with this joint, sure you draw that one. But if you didn't know, you'd always draw this one. Is everybody with me? So when you've got 2 sets, they're almost always going to draw it this way. When it's 3 sets, they're always going to draw it what? That way. So what we're going to do next week is 2 things. For homework tonight, I'm going to give you written out like a universal set, an A, a B, and a C, and you're going to work problems like you worked a minute ago. Then next week, what I'm going to do is I'm going to take that same thing and make you draw me a Venn diagram of it. So you've got to fill the numbers in. Everybody with me? I want you to see what they look like before you got front of them. Now, where's your homework always going to be? On Moodle. Now, they give you a preview of coming attractions. Starting next week, pop tests are going to start regularly. You've got a couple of weeks to get your act together, right? Getting used to Zoom and getting used to being in here. So if Tuesday they have a pop test in class, you don't have the pop test because you're on Zoom. Everybody with me? But if I were you, I'd write the problem down and work it and see if I would have gotten it wrong. If you come in on Thursday, you won't have the same test or even on the same material necessarily. So I'd be looking at the problems for both, but the grades are going to come from in.